Today we're going to talk about simplifying complex fractions. So a complex fraction is a fraction where the numerator the denominator or both contain fractions. So we can see some examples in the notes. This one right below, you've got fraction within a fraction. So to simplify them, you multiply the numerator and the denominator by the lowest common denominator of all the fractions in the complex fraction. Simplify by canceling like factors, and sometimes you can even factor further. So for the first example here, I will write it out as 1 over 1 plus 2 over x divided by 1 over 1 minus 4 over x squared. So I'm looking at the denominators. There's 4 of them. I'm looking at the 1, the x, and the x squared and the 1. What is the LCD? Well, the lowest common denominator is x squared. I'm looking for what I could multiply so that they could all be the same. I'm not looking for what I could multiply. I'm looking for the value that I could replace these all with. They could all be replaced with x squared. So now I'm going to multiply by x squared over 1 and x squared over 1. Oops. Okay, so what I've got here really is a form of 1. X squared over 1 divided by x squared over 1. That's really a form of 1. And I'm taking a monomial times a binomial in both numerator and denominator. And what I want to do is distribute. So what we often do, rather than trying to do a lot in our head, is write the 1 over 1 plus 2 over x and the 1 over 1 minus 4 over x squared, and we just multiply each term by that lowest common denominator over 1. And then I can cancel like factors. So the x squareds here cancel. The x squared and the x cancel here to just leave you with an x. And then if you look at all your denominators, they now have simplified to 1. So you no longer have a complex fraction. So we have x squared plus 2x over x squared minus 4. And then from there you can factor out a GCF and a difference of perfect squares. And so your final answer is x over x minus 2. Okay? So it kind of wraps around there. On the next examples, we'll do the same thing. So I'm not going to go through it as in depth though. So I'm just going to write this as y over 3 plus 1 over 1. Y squared over 3 minus 3 over 1. So I can see my LCD is 3. So what I'm going to do is multiply each term by 3 over 1. Really, you're distributing. Some of you might think, well, why aren't you getting the denominators all the same? Well, there is another way to do that, but this way, the way that I'm doing it and showing you is more efficient sometimes, most of the time, okay? So now the 3's here cancel, and the 3's here cancel. And we are left with y plus 3, because this is all simplified to y over 1, which is just y, 3 over 1, y squared minus 9. And so factoring that further, we get y plus 3 and y minus 3, the difference of perfect squares, and you can cancel those, leaving you with an answer of 1 over y minus 3. But these directions say list any values of the variables for which the fractions are not defined. So the fractions are not defined for values when y is equal to 3 and negative 3. So y cannot be 3 and negative 3 from up there. All right, number 2. I've got to erase something here. Okay, so number 2, it's 1 over 1 minus 1 over w divided by 1 over w squared minus 1 over w. So again, the LCD is the largest of the exponents, so w squared. So I would now take and multiply by w squared over 1 to each term. And what this does is efficiently takes a complex fraction and turns it into a simple fraction, because we can cancel the w squareds there, leaving us with just 1. Here we can cancel w and w squared, leaving us with w, and the same thing down in the denominator. So we're left with w squared minus w over 1, that's not 0, can't leave that, 1 minus w. And I can GCF factor the top, so numerator is w times w minus 1 over 1 minus w. And remember, when they're reversed and the signs are both negative, they simplify to negative 1. So this just becomes negative w for the answer. This fraction would be undefined, can't have w be 0. And right here we've got a fraction, and we cannot have w be 1 either. All right, next page. Okay, for number 3, I think I can just make that over 1 right there. Now on this one, the LCD is 9n squared. So I'm going to multiply by 9n squared over 1, 9n squared over 1, 9n squared over 1, and 9n squared over 1. And see what cancels. So this 9n squared completely simplifies. 9n squared divided by 3n squared leaves me with 3. 9n squared divided by n leaves me with 9n. And I believe that's it. So I've got 9n minus 3 over 9n squared minus 1. You cannot cancel anything here. You need to factor before you cancel. So GCF for the numerator, 3 times 3n minus 1. Difference of perfect squares for the denominator, 3n plus 1 times 3n minus 1. Cancel the 3n minus 1s, and the answer is 3 over 3n plus 1. And n cannot be, from the original problem, 0. And from this fraction here, if you set each of these 3n plus 1 and 3n minus 1 equal to 0, they cannot be 1/3 or negative 1/3. All right, on number 4, this is notation from algebra where you have x over 1. Y to the negative 1 means 1 over y to the first, so it's just 1 over y, divided by y over 1, plus x to the negative 1 is 1 over x to the first. And so now my LCD is x times y. So I'm going to multiply xy over 1 to each term. And see what cancels. So the y's here cancel, leaving me with x. And here the x's cancel, leaving me with y. Okay, so now I get x squared y plus x divided by xy squared plus y squared. I think I made a mistake. Maybe somebody caught it. No. I thought I made a mistake. I didn't. This is just supposed to be y. I confused myself here because I, really could have crossed that out. So xy divided by y just gives me x, that x. And this xy divided by x gives me y. All right, so now I'm ready to GCF factor, and I get x times xy plus 1 over y times xy plus 1. Beautiful. So those cancel, and I'm left with x over y. And this one I am not going to talk about what makes the value of the variable undefined, because we've got two variables. It's a little complicated, so we'll skip that one. Oh, must be number 5 is back here. And there it is. It was hiding on me. Okay, so for number 5, the LCD is 4x. So I'm going to multiply again by 4x over 1, 4x over 1, 4x over 1, and 4x over 1. And then cancel the x. I'm left with the 4 there. Canceled the 2. I'm left with the 2. Cancel the 4, I'm left with an x in there, and cancel the x, I'm left with a 4. So now I have to remember I've got 2 times x times x. So that gives me 2x squared minus 8 times 4, which is 32, divided by x times 1, which is x, minus 1 times 4, which is 4. And then GCF factor the numerator, 2 times x squared minus 16, and then difference of perfect squares, factor that. And then cancel. So you get 2 times x plus 4, or 2x plus 8. And x cannot be, if you look back, the original fraction cannot be 0. And if you look at this fraction in the middle here, it cannot be 4. All right, number 6. All right, let's write this out. 1 over x plus 1 over 1 and 1 over 1 plus 3x plus 2 over x squared. So now the LCD looks like it's x squared. So x squared over 1, x squared over 1, x squared over 1, x squared over 1. The x squareds cancel. There, here you just get left with x. And we'll get x plus x squared in the numerator, all divided by x squared plus 3x plus 2 in the denominator. And then factor that. So GCF for the top, x times 1 plus x. Factor x out, distribute it back, you get x plus x squared. And trinomial FOIL factor the denominators. So two numbers that multiply to 2 that add to 3, plus 2 and plus 1. X plus 1 and 1 plus x do not cancel to negative 1. They cancel to 1. Final answer, x over x plus 2. And in this problem, x cannot be 0, negative 1, or negative 2. All right, last one, number 7. I believe this is a 7 up there. So we end up with 1 over 1 plus 7 over x minus 2. And again, 1 over 1 plus 3 times x plus 2. So my LCD in this instance is x plus 2 times x minus 2, which we know is x squared minus 4 when you FOIL those. So I'm really going to multiply here by x plus 2 times x minus 2. I'm just keeping it that way so that I can cancel those easily. And x plus 2 times x minus 2. And then this one is just really x squared minus 4 and x squared minus 4. No sense writing that out. Those cancel there, so I'm left with x squared minus 4 plus 7x plus 14. Remember to distribute. In the denominator, x squared minus 4 plus 3x minus 6. Again, we need to distribute that. And then combine x squared plus 7x plus 10 over x squared plus 3x minus 10. Factor if you can. Sometimes they're not going to factor further. So plus 5 plus 2. And in the denominator, two numbers that multiply to negative 10 add to 3. So I think I have to go with 5 and 2 again. But now the 2 is negative. So the x plus 5s cancel. So my answer is x plus 2 over x minus 2. And x cannot be 2, negative 2, because from the original denominator, or negative 5. I'll just put that down here. Okay? So there you have it. Good luck.